All right, we're going to look at different forms of linear functions. Slope-intercept you're already familiar with. Point-slope form and standard form, though, may be new, so we're going to go through how to use those when we're graphing or solving or to get other information that we may need. And then in the next couple days, we're going to graph using all the different forms and write equations using different forms. This is labeled students with blue here, but this makes a booklet. So that everything's in one place, and then we're not going to write anything back here so that you can glue that into your journal so that it doesn't get lost. It stays with everything it's supposed to stay. Okay. So slope-intercept form, that one we already know. Y equals mx plus b, where m is the slope and b is the y-intercept. So when I look at this example, next to x, there's my slope, -3. So the rise I can think of as -3, so we're going to go down. And the run then is just 1. We take that to the right. The y-intercept I know is at 1/2. So if I go to 1/2 and plot that, I want to think about what the ordered pair is right there, and that's 0, 1/2. X-intercept, it's going to hit somewhere on the x-axis. Because my slope is negative, it's going to be right over here close by. But I can't just work my rise and run to plot that and figure out where it's going to be. So what I can do for the y-intercept, see how the x is 0? I know that for the x-intercept, the y value is going to be 0. So I can take my equation and set that 0 equals -3x plus 1/2, and then solve like we've been solving. -1/2, -1/2 equals -3x, divide by -3. When we do that, I get x equals negative divided by a negative is positive, so I don't have to worry about that. And then 1/2 divided by 3, I can put that in my calculator as 0.5 divided by 3, or I can leave it as a fraction 1/2 divided by 3 if you use the fraction feature. You just want to be careful. Or we remember that that's the same thing as multiplying by the reciprocal, so 1/2 times 1/3, x is 1/6. So I'm going to put my 1/6. And so I know that when I graph this, it's going to run really close to 0. And I can still do rise and run even though we're starting in the middle. So we're just going to go 1 full unit, 1, 2, 3 over 1, 1, 2, 3 over 1. We'll work it backwards, 1, 2, 3 over 1. And see all of the points I'm plotting are at that halfway mark because that's where we started, but that's perfectly okay. I can still draw my line. Okay. Now with the table and the mapping, we have choices. I can substitute all those x values in and work it by hand. I can just do the manipulation, or we can go to y equals -3x plus, and if I use the fraction option here, then when I go to my table, I'm going to get nice fraction values that I don't have to worry about simplifying. So we'll just scroll back to -5, 31 over 2, -3, +2, and 10, -59 over 2. Okay. And then the same thing on this side with the mapping. It's the same process. -2 is -11/2. The only thing we want to make sure we're keeping track of is as we go this way, our numbers are actually getting more negative, right? Our y value is getting more negative. So we're going to write these backwards to keep them in order from least to greatest. So when we go back to -2, that's the farthest over here to the left on the x we're going to go, so that's the highest y value. So we're going to write that at the bottom, 13/2. 0 is 1/2. 1 is -5/2. And 4, -23/2. Okay. Same information, just different ways of representing it. Okay. So let's go to point slope form. This, to me, is one of the most useful forms, and it's a format that's going to stick with us through all kinds of topics in math. And that's y minus y1 equals m times x minus x1. Well, this m is the same m it was in slope-intercept. That's our slope. But now, instead of giving us specifically the y-intercept, we take the y and the x1s to make a point that can be anywhere on the line. So if I use this slope of 1,4 and the point 8,3, so there's my x1 and my y1. Y minus y1 equals m times x minus x1. I'm going to keep the y minus, we're going to substitute in the y1, substitute in the slope, x minus, substitute in the x1. So that when we come back in, 3, 1/4, and 8. We've written the equation of the line. This is an equation. It's perfectly usable, ready to go. It's in point slope form. We can do stuff with it. We need to be careful, though, that we pay attention to when I look at this, that 3 looks like it's negative. I have to remember that the subtraction comes with the formula, and that what we plugged in was a positive 3. And so here's what we mean. When we have the equation already given to us, y minus 5 equals -2x plus 3. Okay? The -2 is the slope. So I know that my rise, -2, we're going to go down. My run is +1, we can go to the right. But the point that we need, y1 is here, the subtraction came with the formula, so y1 is +5. But here, this has to come from minus a -3 to get that plus. So this is -3, 5. So I'm going to go to that point, -3, +5. And I can graph my line using slope. 1, 2, 1. Without having to try to go back to slope-intercept form or rearrange it, right? And then once that's done, I can see my y-intercept at -1. my x-intercept right here, it's exactly in between those two. So we went down 1 over a half, negative 1/2, 0. And then let's check our graph, f of negative 2. So if I go to where x is negative 2, I follow that up, positive 3, f of 1, follow that down, negative 3, f of 4, well, we didn't quite get there yet, but we can. 1, 2 over 1, 1, 2 over 1, so that was 7, 8, 9. Right. And to check that, I can go back and take my formula, y minus 5 equals negative 2 times x plus 3, and simplify. Y minus 5 equals negative 2x minus 6, add the 5, y equals negative 2x minus 1. Now it's in slope-intercept form. Same y-intercept, same slope. We know we're good with our graph. Okay. Last one we're going to look at is standard form. Standard form generally just written ax plus by equals c. So neither x nor y have been isolated. But what's nice about this is I can get the intercepts in a pretty straightforward way. Right? So my y-intercept, I know that happens when x equals 0. So I'm going to take my equation, negative 6x plus 3y equals negative 18. I'm going to put a 0 in for x. And when I multiply that, I'm left with just 3y equals negative 18. Divide by 3. So y equals negative 6. I know my y-intercept. And we'll go plot it. Same thing with the x-intercept. We go back. Negative 6x plus 3y equals negative 18. My y value now is 0, so we put that in here. Negative 6x plus 3 times 0 equals negative 18. And the same kind of thing happens, divide by negative 6. And we know that x equals positive 3. So I can go to positive 3. And with those 2 points, I can draw my line and start figuring some other things out. Okay? I can get my slope from here, because if I count 6 over 3, so my rise is 6, my run is 3, it's a positive slope, and that simplifies to 2 over 1, which if I come back and test it, 1, 2 over 1, right on our line. 1, 2 over 1. Right exactly there. 1, 2 over 1. It works. So the slope is 2. Okay. If we go to fill in our table, negative 2, it's not on our graph, and it's maybe further down than we're willing to be comfortable checking. Negative 1, it's not exact. We could figure that out. But let's go to positive 1. That one we plotted. That's negative 4. And 2 is at negative 2. Right? So if we work backwards, that was 1. This was plus 2. So if we go backwards in our table, right, we're going to go down 2 over 1. Right? We're 2 more down, negative 2. But what we want to be careful with is we went down to but we were already at -6, so we need to make sure we're tracking where we actually are, just not how far we go. So that if I'm going to go one more time, 2 below that, since we're working backwards, I'm going to take 2 away, then I know that that should be at -10. Okay. Lots more practice with these in classes over the next couple of days, writing, graphing. The only other thing we could probably add here is, how do I get this rearranged so that I can put this in my calculator, right? We had to just figure these out on our own. Well, we're going to take -6x plus 3y equals -18, and I need to isolate the y. So we'll move the 6x. That leaves 3y equals -18 plus 6x. And then we divide everything by 3 so that we get y equals -6 plus 2x. That's just slope-intercept form. Here's my y-intercept and my slope of 2. So again, we've made it into a form that is easier for us to work with, maybe because it's more familiar, but we've also got that y by itself so that we can pick up a calculator and use that to check what we're doing.